Hi, I'm going to show you today how you integrate SonarG with a big data lake initiative. Now, SonarG itself is a big data solution for Guardium, but it was built specifically to understand this data and parse this data, so it's got all the right structures. Whereas sometimes the big data lake is a bigger initiative, um, so you can use SonarG as a preprocessor to facilitate the movement of the data from Guardium into SonarG in an easy way and get it in the format that you want, etc. So it's a very good match. And the pattern of moving the data or the integration between SonarG and a big data lake, there's really two patterns to that. The first is a push pattern, and the second is a pull pattern. In the push, what we normally do is you can get all the data from SonarG into a Kafka queue. And so as the data comes in from the Guardium appliances, it could be queries, it could be session data, it could be outliers, it could even be classification and vulnerability assessment results. That data is then published into a Kafka topic or a bunch of Kafka topics. And you can either move the raw data, or what is more typical is you do some pre-processing on SonarG and you move the data in the format that is best suited for your lake. The other pattern is that the lake can, or scripts or programs running within the lake environment can pull data from SonarG. SonarG does not use MongoDB, but it is wire level compatible with MongoDB, and there are about 500 to 700 different connectors. One of the connectors are the Hadoop connector and the Spark connector. So you can use those in order to pull the data from SonarG directly from, say, some kind of a Hadoop environment, or if you're using Spark, you can read from Spark. But of course, there are a lot of other connectors, like a Python connector, an R connector, an Alteryx connector. There really are a lot of connectors out there. So what I'm going to do is I'm going to show you um, a few of these scenarios, and in all these scenarios, I'm going to use the system. The system has data from Guardium for about a year and a half, which means it has a large set of data. And the first thing I'm going to do is I have a Kafka queue running. And so what I'm going to do is I'm going to start just a basic consumer of attaching to the Kafka server. And I'm just going to show you how easy it is to get the data out. So what I have here is I'm going to push some SQL activity to Kafka. Okay, so what happens is this is defined as either a job or as a stream, and so as data comes into Guardium, I push it to Kafka, I give it the Kafka server. Now in this case, I don't have authentication turned on, so I can just put my Kafka server directly, but if you're using SSL or you're using Kerberos, what you do is you configure this, with a trust store, etc., and then you put an alias over here to push to your Kafka queue, and then the topic you would put in here. And here I was listening. You can see here I was listening to this topic. Okay, to the lake is the name of my topic. And so the records that are being dumped into this Kafka queue, each one of them looks like this. Okay, so this is this is data that comes from Guardium. And in this case, what I'm passing are records that have failures in them. So they will all have some kind of failed SQL. So again, it shows you that you don't need to pass all the raw data. You can pass all the raw data, but you can also pass the right profiles and data sets that you want, and also you can get it in a form that you want. So in my case, I'm passing these as JSON documents because it's very easy to parse on the other side. So each record is a JSON. You can see there's an ID, there's an instance ID, there's how many failed SQLs. More importantly, you can see here that this data is already parsed. Instead of giving you just raw select statements, which means that, or full SQL statements, which means that on your data lake you would have to now parse SQL, which is not that simple. What we're passing is already something that you can consume more easily, because it says there was a select done on this table and a select done on this table. And again, this just is in a format that's very easy to consume. It's a bunch of verbs and objects with a semicolon between them. And of course, if you wanted to get them separately, then we would split it. All these are operators that run within SonarG. So that's one example, and really you have full control within SonarG on what gets passed, because behind each one of these publishers is a definition of how you construct the key and the value that get published to the Kafka queue. And so really, this is something called a pipeline. So in my case, really what's important, or the place where you define all this is here in the projection. And in the projection, you define what is the key and what is the value. So in this case, I'm just converting everything to a JSON document. But for example, if you wanted to get it in a totally different format, like a CSV format or any of your custom formats, all you would do is change this projection and say, how do I construct a value from the data that is the raw data? So it's very easy to make it a really good preprocessor for what you want. The other example I'm going to show you, which also is an example of this pre-processing that's done on the SonarG side, is I'm going to use a data set that now has some return data. Okay, so instead of passing just the SQL statement, also based on certain criteria, pass over data that has been extracted from the database and passed to the client. So imagine that you have some sensitive data in the database, and you want to know which users have been pulling which sensitive data from the database. So Guardium has the facility within its policies to start logging return data, and that data makes it over into SonarG. And then SonarG can pass it in the format that you want into the Kafka queue. So in this example, what I have was really, again, I'm passing JSON. I can pass it in another format. But the two important things are, first, you get the entire full SQL statement. So this is the full SQL statement of an event that touched sensitive data. So there was a select of a bunch of fields from a certain table. What's more important is this is marked as accessing sensitive data, and we know which data was actually extracted from the database, so we can pass it to the Kafka topic. In this case, this is a credit card number, and you can see here it's a log of a MasterCard. If I scroll up, I should see other things as well. So this is an American Express credit card. And this is, for example, a social security number. And again, the return data is the data that matches whatever we're parsing out of the return data stream, and sometimes the parsing is done on the Guardium side, sometimes the parsing is done on the SonarG side. In any case, you can get the data in a format that is useful for within your data lake. Okay, so this is kind of the first part, which is the push. Okay, under these scenarios, SonarG is getting the raw data from Guardium and then moving the processed data or pre-processed data into the data lake. In the second example, I have a Hadoop system, and the Hadoop system can pull the data directly from SonarG using MapReduce, Pig, Hive, any of the stacks within Hadoop, and the key is, and this is where things come in regarding the how open SonarG is. In this case, what you need to do is use the MongoDB connector for Hadoop. So just Google this, and you'll see how to use this, but I'll show you an example. So what I'm going to do is I'm going to connect to Hive. So this is a Cloudera distribution, but this will work regardless of which distribution. Okay, so I'm connecting to Hive, and the key for making any access into SonarG are these libraries, and these libraries are the Hadoop MongoDB connector. Okay, so I add these jars, right? These are the Mongo driver, the Mongo Hadoop core, and the Mongo Hadoop Hive, because I'm going to be using Hive. And at this point, any data that lives in SonarG is accessible directly from Hive, okay, using the MongoDB Hadoop connector. So for example, I have a session table. This data lives inside SonarG. However, to Hive, it looks like a native table, and then I can run any query on it. I can do a select star. Right, so this is what I did. Oh, maybe I should, let me just copy it in without arrow up. Select star from the session table and any condition. And again, this data that you see, each one of these lives within SonarG. So even without moving it, you can access it from your Hadoop environment. And the key is, of course, to map kind of the schema within Hive or whatever the stack is to the collections that live in SonarG. So I'll give you an example of what that looks like. I do a show create table. So you can see that the key is that it's using a Bison serde, because the way it lives inside SonarG is as Bison documents, and the connector is what gives me access to this, right? So this is a class within the MongoDB Hadoop connector, and then you map what the fields are to the fields within SonarG, and you can see the mapping is totally trivial. In my case, the only difference is I've turned every space into an underscore, but that's really all it is. And then I tell it where does the data live so that the Hadoop MongoDB connector can access it. And that's it. And then you can use the data. And in the same way that you can do that, you can use the MongoDB connector for Spark in order to access the SonarG data directly within your Spark jobs. And so what that looks like is, I'm using PySpark. So I just run this script. The script then connects pulls the data from SonarG, it does a certain analysis. In this case, it looks at the data. It gives me per each of the database server type, like DB2 or Sybase or MySQL. It gives me all the name of the users that are connecting to the server. And then if you want to see what's, so it's kind of hard to demo something, but it's very simple to look at it in the script that I ran. And I'm just using one where I've obfuscated the connection properties. So again, the key is this line over here, right? The import PyMongo Spark and then the PyMongo Spark activate. That's what allows me to connect the SonarG from Spark. And then the config tells me where the data is. And at that point, I can directly create my RDDs. So in this case, I'm creating an RDD, and then I'm doing some grouping, and I'm telling it what to aggregate on. So everything in Spark is completely normal. You can use Spark, Spark SQL, anything that you have in Spark. And the data is just being accessed from SonarG. So this has been a very quick demo of Hadoop access, Spark access, and the use of Kafka topics to move data from SonarG into a data lake. For more information, please visit our website, jsonar.com. Thank you.